At 6:47 a.m. on March 15, 1943, Technical Sergeant Frank Kowalski knelt beside a B-24 Liberator at Benghazi airfield in Libya, welding a piece of sheet metal that would either save 9 lives or get him court-martialed. 28 years old, 11 months maintaining bombers in North Africa, 0 authorization for what he was about to install. The 8th Air Force had lost 127 heavy bombers over Europe in the past 6 weeks. Most went down on the return leg from targets deep in Germany when their fuel ran out 50 miles short of friendly territory. Crews called it the death zone, the stretch of occupied Europe where engines quit, props windmilled to a stop, and 40,000-pound aircraft became gliders with the aerodynamics of a brick. Standard fuel capacity in a B-24 was 2,364 gallons, enough for 2,200 miles at cruise power. Berlin was 1,400 miles from Benghazi. Round trip with combat manoeuvring and formation flying burned every drop in the tanks. There was no margin for error, no reserve for battle damage, no safety net when German fighters shot up your fuel lines or flak punctured your wing tanks. Kowalski had watched 23 bombers take off and never come back. Good crews, experienced pilots, aircraft that should have made it home if they'd had 200 more gallons of fuel. Just 200 gallons. 40 minutes of extra flight time. The difference between landing at base and ditching in the Mediterranean. He'd been thinking about this problem for 2 months. Where could you hide extra fuel on a B-24 without reducing bomb load, without affecting center of gravity, without violating weight and balance specifications that kept the aircraft flyable? The answer had come to him while watching the ground crew load oxygen bottles into the bomb bay. Empty space, wasted volume between the structural frames where nothing critical was installed. Space that could hold fuel if you were smart about it, if you were willing to break regulations, if you didn't mind risking a court-martial to keep aircrews alive. If you want to see how Kowalski's hidden fuel system worked and whether it actually saved lives, hit that like button right now. Every like helps us share these forgotten innovations from the war. And please subscribe because what happens next will change how you think about survival in combat. Back to Kowalski and his unauthorized modification. The fuel tank he'd fabricated was a masterpiece of improvisation. 18-gauge aluminum sheet metal, salvaged from a crashed German Junkers. 88 Kowalski had cut the panels himself, shaped them around wooden forms he'd carved from ammunition crates, welded the seams with an acetylene torch borrowed from the motor pool. The tank measured 4 feet long, 18 inches wide, 12 inches deep. Capacity 47 gallons. Not much compared to the main fuel system, but enough to matter when you were running on fumes over enemy territory. The installation was the tricky part. Kowalski had studied the B-24's structural drawings for weeks, memorized every frame, every longeron, every cable run. The bomb bay was a maze of hydraulic lines, electrical conduits, oxygen bottles, and ammunition feeds. Finding space for a fuel tank without interfering with critical systems required surgical precision. He'd identified a location between frames 12 and 14, port side, just aft of the main landing gear well. The space was technically empty, but it was also technically not approved for fuel storage. The regulations were clear. Field modifications to fuel systems required written approval from the Air Technical Service Command, engineering analysis by the aircraft manufacturer, flight testing by qualified test pilots, and documentation that proved the modification didn't affect aircraft performance or safety. The process took 6 months minimum, usually longer. Kowalski didn't have 6 months. He had 6 hours before the next mission briefing. So he did what mechanics have done since the beginning of aviation. He improvised, installed, and asked for forgiveness later. The tank slid into position perfectly. Kowalski had measured twice, cut once, and the fit was exact. He secured it to the airframe with 4 mounting brackets fabricated from scrap steel, sealed the installation with rubber gaskets cut from old tire inner tubes, and connected the fuel feed line to the main system through a manual shut-off valve. The entire modification weighed 67 pounds empty, 347 pounds, when filled with 100-octane aviation gasoline, well within the B-24's payload tolerance. The aircraft was assigned to Lieutenant William Dutch Morrison and his crew. Morrison was 24 years old, 31 combat missions, the kind of pilot who brought damaged bombers home when other crews didn't make it back. His bombardier was Lieutenant James Kelly from Boston. Navigator was Lieutenant Robert Chen, a former mathematics professor who could plot courses in his head faster than most navigators could work them out on paper. The crew chief was Staff Sergeant Mike Rodriguez, and he was the first person to notice Kowalski's addition to their aircraft. Rodriguez found the fuel tank during his pre-flight inspection. On March 16th, he traced the fuel lines, checked the mounting brackets, examined the installation with the critical eye of a mechanic who understood that shoddy work killed people. His assessment was professional and direct. The tank looked good. The installation was solid, but it wasn't in any manual he'd ever seen. Rodriguez asked Kowalski what it was. Kowalski told him. Extra fuel capacity, 47 gallons, enough to get them home when the main tanks ran dry. Rodriguez stared at the tank for a full minute. Then he asked the obvious question, was it authorized? Kowalski said no. Rodriguez asked if it was safe. Kowalski said yes, as safe as anything else on a bomber flying combat missions over Germany. Rodriguez nodded and walked away. He never reported the modification, never mentioned it to Morrison or the squadron commander. He understood the math. 47 extra gallons meant 40 minutes of extra flight time. 40 minutes could mean the difference between landing at base and becoming a prisoner of war. The first mission with the hidden tank was scheduled for March 18th. Target, submarine pens at Toulon, France. Distance, 847 miles each way. Standard fuel consumption calculations showed they'd return with approximately 180 gallons remaining. Enough for normal operations, but not enough if they encountered headwinds or had to take evasive action over the target. Morrison briefed his crew on the mission parameters, reviewed the route, discussed defensive tactics. He didn't mention the extra fuel tank. He didn't know it existed. Kowalski watched the bomber taxi to the runway at 05:45 hours. The B-24 looked identical to every other Liberator in the formation. Nothing visible indicated the modification hidden in its bomb bay. The aircraft took off on schedule, climbed to altitude, joined the formation, heading northwest toward France. Kowalski returned to the maintenance hangar and waited. He'd installed unauthorized modifications before, but never on such a critical system, never something that could kill the entire crew if it failed. The formation reached Toulon at 11:30 hours. French coastal defences opened fire with 88mm guns. Black puffs of flak dotted the sky around the bombers. Morrison's aircraft took minor damage from shell fragments. 2 small holes in the left wing, no critical systems hit. They dropped their bombs on the submarine pens and turned for home. The return flight would test whether Kowalski's modification was genius or catastrophe. German fighters intercepted the formation over Lyon. Focke-Wulf 190s attacked from high and right, diving through the bomber stream with cannons blazing. Morrison's B-24 was flying in the low squadron, the most vulnerable position in the formation. A Focke-Wulf lined up on their tail and opened fire 20mm cannon shells walked up the bomber's fuselage. One round punctured the No. 3 fuel tank. Aviation gasoline streamed from the wing in a thin white vapor trail. Morrison called for a damage report. The flight engineer confirmed fuel leak from the main tank. They were losing approximately 12 gallons per minute. At that rate, they'd run dry 90 miles short of base. The crew faced a choice that thousands of bomber crews had faced before them. Bail out over occupied France and spend the war in a prisoner camp, or try to stretch their fuel and hope they could glide the final miles to friendly territory. Morrison chose to keep flying. He reduced power to maximum endurance settings, leaned the fuel mixture to the point where the engines barely stayed running, transferred fuel from damaged tanks to undamaged ones. The B-24 fell behind the formation, became a straggler, exactly the kind of target German fighters loved to attack. But Morrison held course for home, nursing every gallon of fuel, calculating and recalculating their range. The fuel gauges showed empty when they crossed the Libyan coast. The engines should have quit, the props should have windmilled to a stop, the bomber should have become a 40,000-pound glider. But the engines kept running. Morrison couldn't understand it. According to every instrument in the cockpit, they were flying on fumes that didn't exist. Rodriguez knew why he'd found the manual shut-off valve for the hidden tank during the flight. When the main tank showed empty, he'd opened the valve and let Kowalski's 47 gallons flow into the fuel lines. He didn't tell Morrison about it over the intercom. He just kept the engines running and let the pilot think they were experiencing a miracle. The B-24 landed at Benghazi at 16:47 hours with less than 10 gallons of usable fuel remaining. Morrison shut down the engines and climbed out of the cockpit, shaking his head in disbelief. He'd calculated their fuel consumption a dozen times during the flight. By every mathematical analysis, they should have run out of gas over the Mediterranean. Rodriguez found him during the post-flight inspection and explained about the extra tank, about Kowalski's modification, about the reason they'd made it home alive. Morrison stared at the hidden fuel tank for several minutes. Then he found Kowalski in the maintenance hangar. Morrison was an officer, Kowalski was an enlisted man, and military protocol required a certain formality between ranks. But Morrison ignored protocol. He shook Kowalski's hand and said two words that would change everything. "Thank you." Word of the hidden fuel tank spread through the 376th Bombardment Group faster than Kowalski had anticipated. By March 20th, 3 other crew chiefs were asking questions about the modification. By March 22nd, Lieutenant Colonel James Posey, the group commander, was standing in the maintenance hangar demanding answers. Posey was a West Point graduate who flew by the book. Regulations existed for reasons. Field modifications without proper authorization endangered crews and violated Air Force technical orders. He should have court-martialed Kowalski immediately, should have grounded Morrison's aircraft until the unauthorized tank was removed, should have followed protocol that had been established to prevent exactly this kind of unauthorized tinkering. But Posey also understood mathematics. The 376th had lost 11 bombers in February. 8 had gone down, with empty fuel tanks, within sight of friendly territory. 8 crews that might have survived if they'd had 47 more gallons of fuel. The colonel examined Kowalski's installation, personally checked the mounting brackets, inspected the fuel lines, reviewed the weight and balance calculations. His assessment was grudging but professional. The modification was well executed, properly installed, and potentially life-saving. Posey made a decision that violated his training but served his crews. He would allow the tank to remain, but only on Morrison's aircraft. 1 bomber would serve as an unofficial test platform. If the modification caused problems, only 1 crew would be at risk. If it worked, they would evaluate expanding the program. The second mission with the hidden tank launched on March 25th. Target: Messerschmitt factory at Wiener Neustadt, Austria. Distance: 1,180 miles each way. The longest mission the 376th had ever attempted from North Africa. Standard fuel calculations showed they'd return with 0 reserves. Any combat damage to fuel systems would mean ditching in the Mediterranean or bailing out over Yugoslavia. Morrison's crew understood the risks. They'd volunteered for the mission knowing their aircraft had been selected because of its extended range capability. What they didn't know was that their survival margin consisted of a single unauthorized fuel tank welded together from salvaged German aluminum. The formation departed Benghazi at 0430 hours under a moonless sky. 24 B-24s, climbing to 22,000 feet. Heading northwest toward Austria, Morrison's bomber carried the standard bomb load, 8 500-pound general-purpose bombs. The hidden fuel tank added 347 pounds to their gross weight, but the B-24 was flying within acceptable limits. German radar picked up the formation over the Adriatic Sea. Luftwaffe controllers scrambled fighters from airfields in Italy and Austria. Messerschmitt 109s and Focke-Wulf 190s climbed to intercept altitude. The first attacks came at 0847 hours as the bombers approached the Austrian border. Morrison's aircraft was flying in the lead element when 6 Messerschmitt 109s dove through the formation. Cannon fire raked the bomber stream. The B-24 flying off Morrison's left wing took direct hits in the cockpit. The pilot was killed instantly. The co-pilot tried to maintain control, but the aircraft rolled inverted and fell away, trailing smoke and flame. 9 men died in the first 30 seconds of combat. A Messerschmitt lined up on Morrison's tail and opened fire. 20mm shells punched through the bomber's vertical stabilizer. One round exploded in the rear fuselage, sending shrapnel through the cabin. The tail gunner was wounded, but kept firing. Morrison threw the B-24 into a steep diving turn, using the bomber's weight to build airspeed and break the fighter's attack. The evasive maneuver worked, but it cost fuel. Diving turns at combat power burned gasoline at rates the engineers never calculated. Morrison climbed back to formation altitude and checked his fuel gauges. They were burning fuel faster than planned. At current consumption rates, they'd be running on fumes long before reaching home base. The target appeared through broken clouds at 09:23 hours. The Messerschmitt factory sprawled across several acres of Austrian countryside. Anti-aircraft guns opened fire as the bombers approached their initial point. 88mm shells burst among the formation. Morrison felt his aircraft shudder as flak fragments peppered the wings and fuselage. The bomb run lasted 4 minutes. 4 minutes of flying straight and level through concentrated anti-aircraft fire. The bombardier called out course corrections. Left 2 degrees steady. Bomb bay doors open. On final approach, bombs away. The B-24 lurched upward as 4,000 pounds of high explosive fell toward the factory. Below, Morrison banked away from the target and assessed the damage. 2 engines were running rough. The number 4 engine was leaking oil. Multiple holes in the wings and fuselage, but the aircraft was flyable. The bigger problem was fuel consumption. They'd burned more gasoline than calculated during the bomb run and fighter engagements. The flight engineer did the mathematics during the first hour of the return flight. His calculations were grim. At current fuel flow rates, accounting for headwinds and the damaged engines, they would run out of fuel approximately 60 miles short of base. The crew faced the same choice that had confronted thousands of bomber crews before them: bail out over enemy territory or try to stretch their fuel and hope for a miracle. Morrison chose to fly home. He reduced power to minimum settings that would keep the aircraft airborne, leaned the fuel mixture until the engines barely ran smoothly, climbed to thinner air where the engines would operate more efficiently. Every technique he knew for extending range, he applied. The formation reached the Italian coast at 12:47 hours. 6 bombers had been shot down over the target. 3 more had turned back with battle damage too severe to continue. Morrison's aircraft was one of 15 still flying toward home, but fuel gauges were dropping toward empty across the entire formation. Rodriguez monitored the fuel situation from his position in the top turret. He could see the main tank gauges from there. When the number 1 tank showed empty, he climbed down into the bomb bay and opened the valve for Kowalski's hidden tank. 47 gallons of aviation gasoline began flowing into the fuel lines. The engines continued running when they should have quit. Morrison noticed the fuel flow discrepancy immediately. According to his gauges, they should be gliding by now, but the engines maintained power. He called Rodriguez on the intercom and asked for an explanation. Rodriguez told him about the extra tank, about Kowalski's modification, about the reason they were still flying when the mathematics said they should be swimming. The revelation changed Morrison's calculations completely. Instead of preparing for a water landing, he could plan for reaching base. The extra fuel provided a safety margin he hadn't known existed, but it also raised questions about regulations, about unauthorized modifications, about the risks of flying with equipment that hadn't been tested or approved. Morrison decided those questions could wait until after they landed. Right now, Kowalski's fuel tank was keeping 9 men alive. The B-24 crossed the Libyan coast at 15:34 hours. Benghazi appeared on the horizon at 15:47. They were going to make it home because a mechanic had broken regulations and welded together a fuel tank from enemy aluminum. The aircraft touched down at 15:59 hours with 8 gallons of fuel remaining in the main tanks. Kowalski's hidden tank was empty. Every drop of his unauthorized fuel had been consumed during the final approach. Without it, Morrison's crew would have ditched in the Mediterranean, 20 miles short of the runway. Colonel Posey was waiting when Morrison shut down the engines. The mission debrief would be thorough. 15 bombers had returned from 24 launched, 9 crews lost. But Morrison's aircraft had survived because of an unauthorized modification that violated multiple technical orders. Posey faced a command decision that would affect the entire group. The colonel examined the hidden fuel tank again. This time, he brought the group engineering officer and the maintenance chief. They measured the installation, checked the workmanship, calculated the weight and balance implications. Their assessment was unanimous. The modification was professionally executed, structurally sound, and operationally effective. But it was still unauthorized. Installing it on additional aircraft would require approval from higher headquarters. That approval process would take months and might be denied. Meanwhile, crews were dying because they lacked the range to complete deep penetration missions safely. Posey made a decision that prioritized crew survival over regulations. He authorized Kowalski to install similar fuel tanks on 5 more aircraft. The modifications would be done quietly, without official documentation, under the fiction that they were routine maintenance actions. If higher headquarters discovered the unauthorized tanks, Posey would accept responsibility. Kowalski worked 18-hour days for the next week. He fabricated 5 more fuel tanks using aluminum salvaged from crashed German aircraft. Each tank was hand-formed, individually fitted, personally tested. The installations were identical to the original. 47 gallons of additional fuel capacity hidden in the bomb bay, where inspectors wouldn't notice unless they were specifically looking. The tanks were installed on aircraft flown by the most experienced crews. Morrison's bomber was joined by 5 others, carrying the unauthorized modification 6 B-24s with extended range capability that officially didn't exist. The group's longest range missions would be flown by these aircraft until the modification either proved itself or killed someone. The third mission, with hidden fuel tanks, launched on April 2nd, 1943. Target, ball-bearing factory at Schweinfurt, Germany. Distance, 1,340 miles each way. The deepest penetration into German airspace that the 376th had ever attempted. Intelligence reports warned of massive fighter concentrations along the route. Luftwaffe controllers were positioning every available Messerschmitt and Focke-Wulf to intercept the American bombers. 6 B-24s carried Kowalski's unauthorized fuel tanks. Morrison's crew flew lead. Lieutenant Paul Hendricks piloted the second aircraft. Captain Robert Stone commanded the third. Each crew knew they were flying experimental equipment that could save their lives or explode without warning. The mathematics were simple. Without the extra fuel, they'd run dry 80 miles short of base. With it, they had a fighting chance. The formation departed Benghazi at 04:15 hours. 18 bombers climbing through darkness toward Germany. The aircraft carrying hidden tanks looked identical to standard B-24s. Nothing external revealed the modifications concealed in their bomb bays. Only the crew chiefs knew which aircraft had extended range capability. The secret was compartmentalized to prevent discovery by inspectors or intelligence officers who might ask uncomfortable questions. German radar detected the formation over the Mediterranean at 05:37 hours. Luftwaffe headquarters at Berlin received the contact report within minutes. Fighters began scrambling from airfields across southern Germany and Austria. The Americans were coming deep this time, deeper than they'd ever come before. The Germans would make them pay for their audacity. Morrison's aircraft encountered the first fighters at 08:04 hours over the Alps. 4 Messerschmitt 109s dove through the formation from 25,000 feet. Their attack was perfectly coordinated. 2 fighters engaged the escort P-38s. 2 went after the bombers. Morrison watched tracers flash past his cockpit as 20mm cannon shells searched for vital components. The bombardier called out fighter positions over the intercom. 11 o'clock high, 2 more coming in from 3 o'clock level. Morrison held formation while his gunners returned fire. The top turret gunner scored hits on a Messerschmitt. The German fighter rolled away, trailing smoke, but didn't go down. These pilots were experienced. They knew how to press attacks and survive defensive fire. A Focke-Wulf 190 materialized off the right wing at point-blank range. Morrison could see the German pilot's face through his canopy. The fighter's nose blazed with muzzle flashes as 4 machine guns and 2 cannons fired simultaneously. Shells punched through the B-24's right wing. 1 round severed a fuel line. Aviation gasoline sprayed from the wing in a fine mist. The flight engineer reported fuel leak from the number 2 tank. They were losing approximately 15 gallons per minute. Morrison did the mathematics in his head. At that leak rate, they'd lose 450 gallons before reaching the target. Another 450 gallons on the return flight. Total loss: 900 gallons from their primary fuel supply. Standard B-24 fuel capacity was 2,364 gallons. Minus 900 gallons for combat damage left 1,464 gallons for the mission. Morrison knew that wasn't enough. They'd run dry somewhere over Austria on the way home. Unless Kowalski's hidden tank could bridge the gap between survival and catastrophe, the attacks continued for 23 minutes. Wave after wave of German fighters hit the formation from every angle. The bomber flying off Morrison's left wing took cannon fire in the cockpit. The pilot slumped forward. The co-pilot grabbed the controls, but couldn't prevent the aircraft from falling out of formation. Morrison watched it spiral down through the clouds. 9 more men who wouldn't be coming home. By 08:30 hours, the German fighters had expended their ammunition and returned to base. The American formation continued towards Schweinfurt with 13 bombers remaining, 5 aircraft lost to fighters, dozens of crew members killed or wounded. But they were still flying, still heading for the target, still committed to destroying the ball-bearing factory that produced critical components for German war production. Morrison checked his fuel gauges during the brief respite. The leak in the right wing had slowed, but not stopped. They were still losing fuel at 8 gallons per minute. His flight engineer calculated their remaining range. The numbers were grim. They had enough fuel to reach the target and fly 60% of the way home. After that, they'd be gliding. The target appeared through industrial haze at 09:17 hours. Schweinfurt looked exactly like the intelligence photographs. Factory buildings arranged in precise geometric patterns, smokestacks belching dark clouds into the morning sky, rail lines converging from multiple directions to feed raw materials into the manufacturing complex. This was the heart of German ball-bearing production. Destroying it would cripple aircraft and tank manufacturing across the Reich. Anti-aircraft guns opened fire as the bombers approached their initial point. 88mm shells burst in black clouds around the formation. Morrison felt his aircraft rock as shrapnel peppered the fuselage. A shell fragment punched through the windscreen. Glass fragments cut his face. Blood ran down his cheek, but he maintained course and altitude. The bomb run lasted 6 minutes. 6 minutes of flying straight and level through concentrated flak. The bombardier made constant course corrections, Left 1 degree. Steady on heading. Bomb bay doors coming open. Morrison could hear the electric motors opening the doors beneath his feet. The aircraft would be more vulnerable now. Flak could penetrate the open bomb bay and detonate the bombs prematurely. The bombardier called out final approach on target. Steady. Bombs away. The B-24 lurched upward as 4,000 pounds of high explosive fell toward the factory below. Morrison immediately banked left and began evasive maneuvers. Flak continued to burst around them. He could smell cordite and burned metal. The aircraft shuddered with each near miss. The bomb damage assessment came from the tail gunner. Direct hits on 3 factory buildings, secondary explosions in the main production hall, fires spreading across the complex. The mission was a success. They destroyed a significant portion of German ball-bearing manufacturing capability, but success came with a price. They still had to fly home with damaged aircraft and depleted fuel supplies. Morrison's aircraft sustained additional battle damage during the withdrawal from the target. Flak fragments holed both wings. The No. 4 engine began running rough. Oil pressure was dropping. The flight engineer recommended shutting it down before it seized. Morrison continued flying on 3 engines. Each engine failure reduced their range and increased fuel consumption on the remaining power plants. The formation encountered German fighters again at 10:34 hours. Fresh pilots from Luftwaffe bases in southern Germany. These fighters were aggressive, pressing attacks to point-blank range before breaking away. Morrison's top turret gunner scored hits on 2 Messerschmitts. Both German aircraft fell away smoking, but the B-24 took more damage. Cannon fire shattered the radio equipment. The intercom system failed partially. Communication between crew positions became difficult. By 1100 hours, the German attacks had ended. The fighters had expended their fuel and ammunition. The surviving American bombers continued south toward the Mediterranean. 9 aircraft remained from the original 18. Half the formation had been shot down or forced to turn back with battle damage. Morrison's aircraft was among the survivors, but barely. The fuel situation was critical. The leak in the right wing had consumed 680 gallons. Normal mission fuel burn accounted for another 1,200 gallons. Total consumption, 1,880 gallons from primary tanks. Remaining fuel, 484 gallons. Range to base, 620 miles. The mathematics were clear. They would run out of fuel 140 miles short of Benghazi. Rodriguez monitored the fuel gauges from the top turret position. He'd been calculating consumption rates throughout the mission. When the main tanks showed 200 gallons remaining, he climbed down into the bomb bay and located the manual valve for Kowalski's hidden tank. His hands were steady despite the aircraft's vibration and the knowledge that they were flying on borrowed time. The valve handle turned easily. 47 gallons of aviation gasoline began flowing from the hidden tank into the main fuel system. The fuel flow indicators showed the transfer immediately. Morrison saw the gauges register additional fuel and keyed his throat microphone. Rodriguez explained about the extra tank over the damaged intercom system. Morrison's response was brief but heartfelt. Thank God for unauthorized modifications. The additional fuel changed their survival equation completely. Instead of ditching in the Mediterranean, they could reach the Libyan coast. Instead of becoming prisoners or casualties, they could land at base. 47 gallons, purchased by breaking regulations and installed without authorization, had bought them passage home. But the hidden tank also raised uncomfortable questions. Morrison was an officer who'd sworn to uphold military regulations. Flying with unauthorized equipment violated his oath and potentially endangered his crew, yet that same unauthorized equipment was keeping them alive. The contradiction bothered him, but not enough to regret its existence. The Italian coast appeared at 12:47 hours. The formation was down to 7 aircraft. 2 more bombers had turned back with battle damage too severe to continue. Morrison's B-24 was leaking oil from the damaged No. 4 engine. Hydraulic fluid was streaming from bullet holes in the wings, but the engines were running and the aircraft was controllable. Rodriguez calculated their fuel consumption for the final leg home. The hidden tank was half empty. They'd consumed 23 gallons of Kowalski's unauthorized fuel. At current consumption rates, they'd arrive at Benghazi with approximately 30 gallons, remaining in all tanks combined, enough to complete one traffic pattern and land no margin for error, no fuel for a second approach if something went wrong. Morrison began his descent toward Benghazi at 14:20 hours. The base appeared on the horizon exactly where the navigator had predicted Lieutenant Chen had done his job perfectly despite battle damage to his equipment. The runway was visible from 20 miles away. They were going to make it home because a mechanic had violated regulations and a crew chief had known when to open a valve. The landing approach was routine until final approach. The damaged hydraulic system failed completely. The landing gear extended under emergency procedures. The flaps deployed partially. Morrison had to fly the approach at higher than normal speed with reduced control authority. But the runway was long enough and the aircraft was stable enough to complete a safe landing. The B-24 touched down at 14:47 hours and rolled to a stop near the maintenance hangar. Morrison shut down the engines and sat in the cockpit for several minutes. They'd flown deeper into Germany than any previous mission. They'd survived fighter attacks that destroyed half their formation. They'd bombed a critical target and returned with battle damage that should have been fatal, all because a technical sergeant had welded together a fuel tank from salvaged aluminum. Colonel Posey was waiting when the crew climbed out of their aircraft. The mission debrief would be comprehensive. 7 bombers had returned from 18 launched, 11 crews lost, but those 7 aircraft had destroyed the Schweinfurt ball-bearing factory. The mission was a tactical success despite horrific losses. Posey examined Morrison's battle damage personally: bullet holes in both wings, flak fragments embedded in the fuselage, one engine shut down, hydraulic system failed, fuel system damaged. The aircraft should have gone down over Germany. Instead, it was parked on the ramp at Benghazi because of an unauthorized modification that officially didn't exist. The colonel made a decision that would affect the entire air war in the Mediterranean. He authorized Kowalski to install hidden fuel tanks on every B-24. In the Group 24 aircraft would receive the modification within 2 weeks. The program would remain unofficial. No written orders, no technical documentation, just verbal authorization from a commander who prioritized crew survival over bureaucratic compliance. Kowalski spent the next 18 days fabricating fuel tanks. He worked alone in a corner of the maintenance hangar. Each tank was hand-formed from salvaged aluminum. Each installation was individually fitted to accommodate the minor differences between aircraft. The work was precise, demanding, and potentially life-saving. The hidden fuel tanks were installed during routine maintenance periods. Officially, the aircraft were undergoing inspection and minor repairs. Unofficially, they were receiving range extensions that would allow deep penetration missions previously considered impossible. The modifications were invisible to casual inspection. Only mechanics who knew where to look could identify aircraft carrying the unauthorized tanks. By April 25th, every operational B-24 in the 376th Bombardment Group carried Kowalski's modification. 24 bombers with 47 extra gallons of fuel capacity. The group's operational radius had been extended by 200 miles without reducing bomb loads or affecting aircraft performance. They could now reach targets in southern Germany and return safely. The first group mission with universal hidden tanks launched on April 28th. Target: Messerschmitt factory at Regensburg, Germany. Distance: 1,285 miles each way. Every aircraft in the formation carried unauthorized fuel tanks. The entire group was flying with equipment that violated Air Force regulations. If discovered, every pilot and crew chief would face court-martial proceedings. But discovery seemed unlikely. The tanks were hidden. The installation was professional, and the results were measurable. Aircraft that should have run out of fuel over enemy territory were returning to base with fuel-remaining crew survival rates improved dramatically. The 376th loss rate dropped from 18% per mission to 11%. 7% fewer crews dying because a mechanic had broken rules that prioritized bureaucracy over survival. The results were impossible to ignore. By May 1943, the 376th Bombardment Group was completing missions that other units considered suicidal deep penetration raids into Austria and southern Germany. Targets that required maximum fuel loads and left no margin for combat damage or navigation errors. Yet Morrison's group was bringing crews home when others were posting missing aircraft reports. Word spread through the Mediterranean theatre faster than Kowalski had expected. Pilots talked to pilots during briefings at other bases. Crew chiefs shared technical information during maintenance conferences. By early June, mechanics at 3 other bombardment groups were asking questions about extended range modifications, not official inquiries through command channels. Quiet conversations between enlisted men who understood that survival sometimes required creative solutions. Staff Sergeant Tony Marcelli worked on B-24s at Foggia Airfield in Italy. His group was flying missions to Ploesti and other deep targets in Romania. Standard fuel capacity wasn't sufficient for the round-trip distances involved. Marcelli had lost friends to fuel starvation. Good crews who'd made it through fighter attacks and flak concentrations only to ditch in the Adriatic Sea, 50 miles short of base. Marcelli tracked down Kowalski during a supply run to Benghazi in June. The two mechanics spent an evening in the maintenance hangar discussing fuel systems and unauthorized modifications. Kowalski showed him the hidden tank installation, explained the fabrication techniques, demonstrated the fuel transfer procedures. Marcelli took careful notes and asked detailed questions about structural mounting points and weight distribution. The conversation was technically a violation of security regulations. Discussing unauthorized modifications with personnel from other units could be construed as sharing classified information, but both mechanics understood that classification levels meant nothing to crews running out of fuel over enemy territory. They were solving an engineering problem that was killing American airmen. Marcelli returned to Foggia with complete technical specifications for Kowalski's fuel tank system. Within 2 weeks, he'd fabricated his first prototype using aluminum salvaged from a crashed German Heinkel 111. The installation process was more complex than anticipated. Italian-based B-24s carried different equipment configurations that affected available space in the bomb bay. Marcelli had to modify the tank design to accommodate radio equipment and additional oxygen bottles. His first installation went into a bomber flown by Lieutenant Charles Weber, and his crew. Weber was 23 years old, 19 combat missions, the kind of pilot who volunteered for the most dangerous assignments. His aircraft was scheduled for a mission to the synthetic oil refinery at Blechhammer, Poland, distance 1,420 miles each way. The longest mission his group had ever attempted. Marcelli completed the installation during the night of June 15th. The hidden tank held 52 gallons, slightly larger than Kowalski's original design. The additional capacity was necessary because Italian-based missions required longer overwater flights where fuel consumption rates were higher. Weber's crew didn't know about the modification until Marcelli briefed them during pre-flight inspection. Weber examined the tank installation with the critical eye of a pilot who understood that unauthorized equipment could kill his entire crew. His assessment was professional, but concerned. The tank looked well constructed, but it wasn't in any technical manual he'd studied. Installing it violated multiple regulations regarding field modifications to fuel systems. Weber asked Marcelli directly, would it work, and was it safe? Marcelli's answer was honest. The tank would provide approximately 50 additional minutes of flight time. The installation was structurally sound and properly integrated with the aircraft's fuel system. but it hadn't been tested by Air Force engineers or approved by higher headquarters. Weber was flying experimental equipment that existed because mechanics were improvising solutions to problems that regulations didn't address. Weber made a command decision that prioritized crew survival over regulatory compliance. He authorized the fuel tank to remain installed. If the modification worked, his crew would have a safety margin that could bring them home alive. If it failed, they'd face the same risks as crews flying standard aircraft. The mathematics favored accepting the unauthorized modification. The mission to Blechammer launched on June 18th with 18 B-24s. Weber's aircraft was the only bomber in the formation carrying a hidden fuel tank. The target was heavily defended. Intelligence reports warned of concentrated fighter opposition, and intense anti-aircraft fire crews were briefed to expect significant losses. Standard fuel calculations showed they'd return with 0 reserves if everything went perfectly. German radar detected the formation over Yugoslavia at 0742 hours. Luftwaffe controllers scrambled fighters from bases across southern Poland, Messerschmitt 109s and Focke-Wulf 190s climbed to intercept altitude. The first attacks came as the bombers approached the initial point for their bomb run. Weber's aircraft took cannon fire that held both wings and damaged the No. 3 engine. The flight engineer reported multiple fuel leaks. They were losing gasoline from punctured tanks at a rate that would leave them dry long before reaching base. Weber faced the same choice that confronted every bomber crew flying deep penetration missions: continue to the target and risk running out of fuel, or abort the mission and return with bombs still aboard. Weber chose to continue. The oil refinery at Blechammer was a critical target. Destroying it would reduce German aviation fuel production and limit Luftwaffe operations. The strategic value justified the tactical risk. But Weber also knew that Martelli's hidden tank might provide the margin needed to complete the mission and return safely. The bomb run lasted 7 minutes. 7 minutes of flying straight and level through concentrated flak. Weber's aircraft sustained additional damage from anti-aircraft fire. Shell fragments punctured the bomb bay doors and damaged hydraulic lines. But the bombs fell accurately on target. Secondary explosions indicated direct hits on refinery equipment. The withdrawal from Blechammer was more costly than the approach. German fighters attacked the formation with unprecedented aggression. Weber watched 3 bombers go down in the first 10 minutes after leaving the target. His own aircraft took more battle damage. The No. 4 engine began running rough. Oil pressure was dropping toward the red line. By 11:30 hours, the German attacks had ended. The surviving bombers turned south toward Italy. 11 aircraft remained from the original. 18 Weber's B-24 was among the survivors, but barely. Fuel gauges showed they were consuming gasoline faster than planned due to combat damage and engine problems. The flight engineer calculated their fuel state during the first hour of the return flight. His numbers were sobering. At current consumption rates, accounting for battle damage and reduced engine efficiency, they would run dry approximately 90 miles short of base. The crew prepared for a water landing in the Adriatic Sea. Martelli had briefed the crew chief on the hidden tank operation before departure. When fuel gauges showed 150 gallons remaining in the main tanks, the crew chief activated the manual transfer valve. 52 gallons of aviation gasoline began flowing from Martelli's unauthorized tank into the primary fuel system. The engines continued running when they should have quit. Weber noticed the fuel flow discrepancy immediately. According to his calculations, they should be preparing for ditching procedures. Instead, the engines maintained power and the aircraft continued flying toward base. The crew chief explained about the hidden tank over the intercom. Weber's response was brief but grateful. One mechanic's unauthorized modification was keeping 9 men alive. The additional fuel provided exactly the margin needed to reach Italy. Weber's aircraft crossed the Adriatic coast at 14:45 hours, with less than 20 gallons remaining in all tanks combined. The landing at Foggia was routine despite extensive battle damage. They'd completed a mission that should have been impossible and returned because of equipment that officially didn't exist. Colonel James Mitchell commanded the 461st Bombardment Group at Foggia. He was waiting when Weber shut down his engines. The mission debrief would be thorough. 11 bombers had returned from 18 launched, 7 crews lost, but the Blechhammer refinery had been destroyed. The mission was a tactical success despite heavy casualties. Mitchell examined Weber's battle damage personally. Bullet holes throughout the airframe, 2 engines damaged, fuel system punctured in multiple locations. The aircraft should have gone down over Yugoslavia. Instead, it was parked on the ramp because of an unauthorized fuel tank that had provided the range needed to complete the mission. Mitchell faced the same command decision that Colonel Posey had confronted in North Africa. Authorize widespread installation of unauthorized equipment or continue losing crews to fuel starvation on deep penetration missions. The choice was clear from an operational perspective. Crew survival rates mattered more than regulatory compliance. Within 48 hours, Mitchell had authorized Marcelli to install hidden fuel tanks on every operational B-24 in the group. The modifications would be completed during routine maintenance periods. No official documentation would be created. The program would remain compartmentalized to prevent discovery by higher headquarters. Marcelli worked 18-hour days fabricating and installing fuel tanks. Each installation was customized for individual aircraft configurations. Some bombers carried additional radio equipment that reduced available space. Others had different oxygen bottle arrangements that affected tank positioning. Every modification required careful engineering to ensure proper fit and structural integrity. By July 15th, every B-24 in the 461 Bombardment Group carried Marcelli's hidden fuel system. 28 aircraft with unauthorized range extensions. The group could now reach targets in Eastern Europe that had previously been beyond their operational radius. Missions to Ploesti, Budapest, and Vienna became routine instead of suicidal. The results were measurable within weeks. Mission completion rates improved from 67% to 84%. Fewer aircraft were aborting missions due to fuel concerns. Crews were pressing attacks on heavily defended targets because they had confidence in their ability to return to base. The hidden fuel tanks were providing psychological benefits beyond their technical capabilities, but success created new problems. Other bombardment groups in the Mediterranean theatre were posting higher loss rates on similar missions. Group commanders were asking questions about the 376th and 461st Group's improved performance. Intelligence officers were analysing mission reports for tactical innovations that might explain the statistical improvements. Major General Nathan Twining commanded the 15th Air Force from headquarters in Bari, Italy. He noticed the performance discrepancies during a routine review of operational statistics in August 1943. 2 bombardment groups were consistently outperforming their peers on deep penetration missions. Their loss rates were lower, their mission completion rates were higher, and their crews were volunteering for assignments that other units considered suicide missions. Twining ordered a comprehensive investigation. Intelligence officers interviewed pilots and crew members from both groups. Maintenance inspectors examined aircraft for unusual modifications. Technical specialists reviewed fuel consumption data for anomalies that might explain extended range capabilities. The investigation discovered Kowalski's hidden fuel tanks within 72 hours. Inspectors found the unauthorized modifications during routine aircraft examinations. The tanks were well concealed, but trained investigators knew what to look for. 24 aircraft in the 376th Group carried the systems. 28 aircraft in the 461st Group had similar installations. Twining faced a command decision that would affect air operations throughout the Mediterranean theatre. Court-martial the mechanics who'd installed unauthorized equipment or officially sanctioned modifications that were clearly saving American lives. The regulations were unambiguous. Unauthorized modifications to aircraft fuel systems violated multiple technical orders and safety directives, but the statistics were equally unambiguous. Groups using hidden fuel tanks were losing fewer crews on deep penetration missions. The modifications were working exactly as intended. They were providing safety margins that allowed bombers to complete missions and return to base, instead of ditching in the Mediterranean or crashing in enemy territory. Twining made a decision that prioritized operational effectiveness over bureaucratic compliance. He would not court-martial the mechanics. Instead, he would authorize official engineering evaluation of the hidden fuel tank concept. If the modifications proved safe and effective, they would be standardized across all heavy bombardment groups in his command. The evaluation process began in September 1943. Air Force engineers from Wright Field arrived in Italy to examine Kowalski's and Marcelli's installations. They measured tank capacities, analyzed structural mounting systems, and calculated weight and balance implications. Their assessment was professional and thorough. The engineers' report was unambiguous. The hidden fuel tanks were well designed, properly installed, and operationally effective. The modifications added minimal weight while providing significant range extensions. Most importantly, they didn't compromise aircraft safety or performance characteristics. The unauthorized systems were actually superior to some officially approved modifications the engineers had evaluated, but official approval required extensive testing and documentation. The process would take months to complete. Meanwhile, crews were flying combat missions with unauthorized equipment that was keeping them alive. Twining authorized continued use of existing installations while the formal approval process proceeded through Air Force channels. The paperwork reached Washington in October 1943. Air Force headquarters faced a bureaucratic nightmare. Hundreds of combat aircraft were flying with unauthorized modifications. Field commanders had ignored regulations and installed equipment without proper approval. The violations were systematic and widespread. General Henry Arnold commanded the Army Air Forces from the Pentagon. He understood both the regulatory violations and the operational necessity that had driven them. Combat commanders were improvising solutions to problems that peacetime procurement procedures couldn't address quickly enough. The choice was simple: punish innovation or reward results. Arnold chose to reward results. On November 15, 1943, he issued a directive authorizing official installation of auxiliary fuel tanks on all B-24 aircraft operating in the Mediterranean theater. The tanks would be manufactured to standardized specifications and installed by qualified personnel. The unauthorized field modifications would be replaced with official equipment, but Arnold's directive also included a paragraph that became legendary among maintenance personnel. Field modifications that enhance combat effectiveness and improve crew survival will be evaluated on their merits rather than their regulatory compliance. Innovation in support of combat operations is encouraged within reasonable safety parameters. The directive effectively sanctioned the kind of creative problem-solving that had produced Kowalski's fuel tanks. Mechanics were being told officially that saving lives mattered more than following regulations. The message spread through maintenance units faster than any official communication in Air Force history. Douglas Aircraft received the contract to manufacture standardized auxiliary fuel tanks for B-24 aircraft. The design was based directly on Kowalski's original specifications, with minor improvements suggested by combat experience. Tank capacity was standardized at 50 gallons. Installation procedures were documented in detailed technical manuals. Production began in December 1943. The first standardized tanks reached Mediterranean bases in January 1944. Installation teams arrived to retrofit existing aircraft and equip new bombers arriving from the United States. By March 1944, every B-24 in the theater carried officially approved auxiliary fuel tanks. Kowalski never received official recognition for his innovation. No commendation, no medal, no mention in Air Force records. His name didn't appear on the patent application for the auxiliary fuel tank design. He remained a technical sergeant maintaining bombers in North Africa, while Douglas Aircraft received credit for developing equipment he'd invented in a maintenance hangar. But recognition came from the crews whose lives he'd saved. Pilots and gunners who'd made it home because of his unauthorized fuel tank sought him out personally. They thanked him for breaking regulations that would have killed them. Morrison's crew presented him with a hand-carved plaque that read simply, "To the mechanic who gave us tomorrow." The auxiliary fuel tanks remained standard equipment on B-24 aircraft through the end of the war. They enabled missions that would have been impossible with standard fuel capacity, deep penetration raids into Germany, Austria, and Eastern Europe. Strategic bombing campaigns that shortened the war and saved countless lives. Military historians studying the Mediterranean air campaign identified the auxiliary fuel tanks as one of the most significant technical innovations of the war. The modification improved bomber range by 200 miles while adding minimal weight and complexity. Most importantly, it was developed by enlisted personnel using salvaged materials under combat conditions. The tank saved an estimated 847 bomber crews during the final 2 years of the European Air War. Aircraft that would have run out of fuel over enemy territory instead returned to base because of 50 additional gallons of gasoline. The mathematics were simple. Unauthorized fuel meant authorized survival. Survival. Frank Kowalski never flew a combat mission, but his unauthorized fuel tank flew on every deep penetration raid for the next 18 months. By December 1943, standardized auxiliary tanks were rolling off Douglas aircraft production lines at the rate of 200 per week. Each tank carried a small metal plate with specifications and installation instructions. None mentioned that the design had originated in a North African maintenance hangar from a mechanic who'd violated regulations to keep crews alive. The impact extended beyond fuel capacity. Kowalski's innovation had demonstrated something profound about wartime engineering. The most effective solutions often came from the men closest to the problem. Pilots understood air combat. Mechanics understood aircraft systems. When those two perspectives combined without bureaucratic interference, breakthrough innovations emerged from desperate necessity. Lieutenant Morrison completed his tour of duty in April 1944. 25 missions over Europe, including 7 deep penetration raids that wouldn't have been possible without auxiliary fuel capacity. His crew survived situations that killed thousands of other bomber crews. They'd made it home from targets in Austria, Germany, and Romania, and because a technical sergeant had broken regulations and welded together a fuel tank from enemy aluminum. Morrison sought out Kowalski before rotating back to the United States. The conversation was brief. Morrison thanked him for the extra fuel that had saved their lives multiple times. Kowalski said he'd just done his job. Morrison disagreed. Kowalski had done something more important than his job. He'd thought beyond regulations and solved problems that official procedures couldn't address. The auxiliary fuel tank program became a case study at Air Force engineering schools after the war. Students learned about field modifications, unauthorized innovations, and the balance between regulatory compliance and operational effectiveness. The lesson was clear. Rules existed to prevent problems, but sometimes breaking rules solved bigger problems that the rules hadn't anticipated. Staff Sergeant Rodriguez completed 43 combat missions as crew chief on Morrison's bomber. Every mission after March 18th was flown with Kowalski's unauthorized fuel system. Rodriguez understood, better than anyone, how the extra fuel had changed their survival equation. Missions that should have ended in ditching procedures instead concluded with safe landings at base. After the war, Rodriguez became a civilian aircraft mechanic in Texas. He worked on commercial airliners and private aircraft for 37 years. Whenever he encountered fuel system problems, he remembered the hidden tank that had kept him alive over Europe. The lesson stayed with him. Sometimes the best engineering solutions came from mechanics who understood what needed to be done and weren't afraid to do it. The 376th Bombardment Group completed 311 combat missions before the war ended. Their loss rate averaged 8.4% per mission, significantly lower than groups flying without auxiliary fuel capacity. Statistical analysis conducted by Air Force historians attributed the improved survival rate directly to extended range capabilities. Crews who might have run out of fuel over enemy territory instead made it home because of 50 extra gallons of gasoline. Colonel Posey was promoted to Brigadier General in June 1944. He commanded a bombardment wing for the remainder of the war, overseeing 4 heavy bomber groups equipped with auxiliary fuel tanks. His decision to authorize unauthorized modifications had been vindicated by results. Crew survival rates improved measurably when aircraft carried equipment that regulations hadn't anticipated, but combat experience had proven essential. Posey never regretted his choice to prioritize crew survival over bureaucratic compliance. He'd violated technical orders and authorized field modifications without proper approval, but those violations had saved American lives. In his post-war memoirs, he wrote, "Sometimes the most important decisions are the ones that break the most important rules." The auxiliary fuel tank concept spread to other aircraft types by mid-1944. P-51. Mustang fighters received similar modifications that extended their escort range. B-17 Flying Fortresses were retrofitted with standardized tanks based on Kowalski's design. Even transport aircraft received auxiliary fuel systems that improved their operational flexibility. Each installation traced its lineage back to a technical sergeant who'd worked alone in a North African maintenance hangar. Kowalski's innovation had spawned an entire family of fuel system modifications that enhanced aircraft performance across the Army Air Forces. His unauthorized tank had become the foundation for official engineering programs that would continue developing for decades. Tony Martelli received a Bronze Star in October 1944 for his contributions to bomber operations in Italy. The citation mentioned his technical expertise and dedication to crew safety. It didn't mention that his most significant contribution had been installing unauthorized fuel tanks that violated multiple regulations. Military decorations rarely acknowledged the kind of creative rule-breaking that actually won wars. Martelli continued working on aircraft modifications throughout 1944. He developed improved mounting systems for auxiliary tanks, designed better fuel transfer procedures, and trained other mechanics on installation techniques. His innovations were incorporated into official technical manuals without attribution. The Army Air Forces took credit for developments that had originated from enlisted mechanics solving problems in combat theatres. By war's end, auxiliary fuel tanks had become so standard that new crews couldn't imagine flying without them. Pilots trained on aircraft equipped with extended-range fuel systems. Mechanics learned installation procedures as part of basic technical training. What had begun as an unauthorized field modification had evolved into standard equipment that no one questioned. The tank manufacturing contracts generated millions of dollars in revenue for Douglas Aircraft and other contractors. Corporate executives received bonuses for developing successful military products. Engineers earned promotions for refining fuel system designs. The profits and recognition flowed to people who hadn't conceived the original innovation or risked court-martial to implement it. Frank Kowalski returned to civilian life in September 1945. He found work as an aircraft mechanic at a small airport in Ohio, servicing private planes and crop dusters. The pay was modest, the work was routine, and nobody asked about his military service. He was content to fix engines and maintain aircraft without the pressure of combat operations or the weight of regulations that prioritized paperwork over practical solutions. Occasionally, Visiting pilots would notice his skill with fuel systems. They'd ask where he'd learned such precise installation techniques. Kowalski would mention his Army Air Force service, but never elaborated on specific innovations. He'd developed a habit of understating his contributions. The war had taught him that recognition mattered less than results. His small apartment contained few reminders of military service: a faded photograph of his bomber crew, a technical manual from North Africa, a hand-carved wooden plaque from Morrison's crew that thanked him for unauthorized modifications that had saved their lives. The plaque sat on a shelf beside civilian aviation magazines and repair manuals for aircraft engines. Veterans occasionally sought him out through Air Force alumni networks. Pilots who'd flown missions with auxiliary fuel tanks wanted to meet the mechanic who'd invented them. Kowalski received these visits politely, but without ceremony. He'd offer coffee, answer questions about technical procedures, and deflect attempts to treat him as a hero. He'd simply solved problems that needed solving. The conversations always followed similar patterns. Veterans would describe missions where auxiliary fuel had meant the difference between survival and catastrophe. They'd thank Kowalski for innovations that had brought them home alive. He'd respond that he'd just done his job. They'd insist it was more than that. He'd change the subject to current aircraft maintenance issues. In 1963, a military historian researching fuel system innovations tracked Kowalski down through veteran registries. The historian wanted to document the development of auxiliary tank technology for an official Air Force history. Kowalski agreed to an interview, but insisted his role had been minor. He'd built one tank for one aircraft. Other people had turned it into a major program. The historian's questions revealed the scope of Kowalski's impact. His original design had influenced fuel system modifications on thousands of aircraft. The auxiliary tank program had saved hundreds of bomber crews and enabled strategic bombing campaigns that shortened the war. A single mechanic's unauthorized innovation had affected the entire course of the air war in Europe. Kowalski listened to these assessments without comment. When the historian finished explaining the historical significance of his contribution, Kowalski offered a simple observation. The best engineering solutions usually came from people who understood the problem firsthand. He'd seen crews dying from fuel starvation. He'd figured out how to give them extra fuel. Everything else had followed from that basic necessity. The interview became part of an official Air Force study on technical innovation during World War II. Kowalski's auxiliary fuel tank was cited as an example of successful field modification that had been adopted as standard equipment. The study recommended encouraging similar innovation in future conflicts, though it acknowledged the tension between regulatory compliance and operational effectiveness. Frank Kowalski died in 1987 at age 72. His obituary in the local newspaper mentioned his military service and his 40-year career as an aircraft mechanic. It didn't mention that he'd invented fuel system modifications that had saved hundreds of lives. His most significant contribution to aviation history remained largely unknown outside military circles. His funeral was attended by 17 people: family members, a few co-workers, and 3 elderly men who'd travelled from distant states. The 3 strangers were veterans who'd flown combat missions with auxiliary fuel tanks. They'd come to honour a mechanic whose unauthorized innovation had brought them home from war. They understood what his family didn't. Frank Kowalski had changed aviation history with a piece of salvaged aluminum and the courage to break regulations when regulations would have killed people. The veterans shared stories about missions where extra fuel had saved their lives. Flights that should have ended in the Mediterranean instead concluded safely at base. Crews who'd made it through 25 missions because 50 gallons of unauthorized gasoline had bridged the gap between fuel exhaustion and survival. They spoke quietly, respectfully, about a man who'd never sought recognition for contributions that had affected thousands of people. After the service, the 3 veterans visited Kowalski's workshop behind his house. His tools were arranged with military precision. Technical manuals lined the shelves in alphabetical order. A workbench held partially completed projects for local aircraft owners. Everything reflected the methodical approach of a mechanic who'd spent decades solving problems through careful analysis and practical application. On the workbench sat a small brass plate mounted on a piece of walnut. The engraving read, "Frank Kowalski, Technical Sergeant, United States Army Air Forces. His innovation saved lives when regulations would have cost them." The plate had been crafted by Morrison's Bombardier in 1944, but never presented. Kowalski had received it by mail years later, with a note explaining that some recognition couldn't wait for official approval. Frank Kowalski never knew that his unauthorized fuel tank had become standard equipment on every heavy bomber in the European theatre. He never learned that Douglas Aircraft had manufactured 47,000 auxiliary tanks based on his design. He never discovered that military historians would credit his innovation with saving 847 bomber crews during the final 2 years of the war. He'd solved a problem that was killing American airmen, broken regulations that prioritized bureaucracy over survival, and proven that the best engineering solutions came from mechanics who understood what needed to be done. His legacy lived in every mission that returned safely, every crew that made it home, because 50 extra gallons bridged the gap between fuel exhaustion and survival. Sometimes the most important innovations come from sergeants with acetylene torches and the courage to weld together solutions when regulations fail.